Hi, welcome to lab number 3. In this lab, we are calculating mass of the black hole at position x 3 10 to the power 10 and y negative 3 10 to the power 10 using universal gravitational law and momentum principle. In this scenario, we have a system of a star that is revolving around a black hole that is our surrounding, and the only force acting on our system is given to be the gravitational force. We are using momentum principle because we know the positional data for the star given us in a file and the time difference between those positions, and we can use position data to find velocities by dividing the difference in position by time, and that velocities when multiplied with mass gives us momentum. And we can differentiate change in momentum with respect to time to give us mass into acceleration, which is the net force acting on our system. And all those are fed into Python program, and we can calculate the change in momentum with respect to time. The mass of the star is fed in here. The delta t, that is difference in time, is 1 day, 86,400 seconds, fed in here. The initial time is 0. We have the black hole position fed in here, and the data is fed into the respective x and y positions in by this line of code, and those position data is used to compute x component and y component of the velocities. Difference in the respective position differentiated and divided by time will give us velocity, as v is distance by time, okay, displacement by time, and those velocities are used to calculate um, initial and final velocities, which are used to calculate initial and final momentum. Those initial and final momentum is used to calculate the difference in momentum, that is delta p, and delta p when differentiated with delta t will give us the net force. The net force is fed in here, and since that the net force given us is the only force that is acting in our system is a gravitational force, we can use that in uh, universal gravitational law. And the net force is the gravitational force. We can rearrange the universal gravitational law to get the mass of the black hole. As we know the mass of the star, gravitational universal gravitational constant, and we can compute the difference in in distance between star and the black hole. The net force that is acting on the system can be resolved in two forces, that is parallel and perpendicular forces, which is down here. This gives us perpendicular force and this gives us parallel force. This gives us parallel force, that is net parallel force, and this gives us perpendicular force, this is the net perpendicular force. Parallel forces are responsible for the speeding up or the slowing down of the star, and perpendicular force is responsible for the path of the star, that is elliptical or semicircular or anything that it can act. And what we are doing now is we are using the universal gravitational law to find the mass of the star, which has been rearranged to find the mass of the black hole right here. The difference in distance is calculated here, g is here, and we are calculating the mass of the distance. When we run this code, this will give us the mass of the black hole along with the different in the other quantities, that is net force, parallel force, perpendicular force, and radius. The net force, that the mass of the black hole was computed to be 3.1842 into 10 to the power 31, and the net force along with perpendicular and parallel force were decreasing but the radius was increasing, so the star was moving away from the black hole. That explains the decrease in force. And as per the and discussion and questions, the net force is the net force that is acting on a system, is the net force. Fnet is the net force that is acting on the system, and there might be many forces that contribute to that net force, be it gravitational or electric. In our case, that was only gravitational force, so we can write it as change in momentum by time. But when other forces are in place, then we have to calculate those also. So fnet is not always equal to del change in momentum by time. It same holds true for perpendicular and parallel forces, as they are the resolved form of fnet. And yes, it is possible to calculate the value of mass of a new black hole if the positional data remains unchanged and the only force acting on it is gravitational force. Thank you for watching my video, and thanks for grading it.